usual. This one is x minus 7. This one is 7 minus x. They have the same terms. They're in a different order, but subtraction's not commutative. That means I can't change the order for subtraction. But what I can do is to multiply this one by -1. And I picked this problem purposefully because we have a similar one on our quiz. So this times -1 is going to give me -7 plus x. Well, what do you know about -7 plus x? Isn't that the same as x minus 7? Okay. Because I recognize that these two were exactly the opposite of each other, and that -1 trick helps me to find a common denominator. Okay? So anytime they're exactly opposite, this -1 piece is going to help you find a common denominator. So the common denominator is this. This is the common denominator. This is the least common multiple. And so I have to multiply, actually I don't have to multiply it by anything because I just factored out a -1, right? So this is 1 over x minus 7, right? And this one is minus, can I rearrange this and write this as x minus 7 times -1. Now here's the tricky part. Can I put that -1 in the numerator without changing the problem? So this -1 down here, I'm going to move it up to the top because that makes the problem easier, right? And remember, when you have this, -3 over 5, that's the same as -3 over 5 or 3 over -5. Those are all the same thing, right? So all I'm doing to make this problem a little easier to work is moving that -1 to the top, okay? So I'm going to make this -12 up here, and that takes care of this, right? So the -1 is now no longer in the bottom, it's in the top. And now my denominators match. So this common denominator was pretty easy if you know that -1 trick. What is 1 minus -12? 1 minus -12, isn't that 1 plus 12? So it's 13, very good, Sadika. So that's 13 over x minus 7. And x cannot be 7. So there's my answer. Okay, so let's talk about it a different way. All right, here's number 3. And this one is addition. So since on the quiz that you guys are taking, all of these will be mixed up, it's imperative that you pay attention to the operation because there's different steps for different operations. So the first step is always, in all of the operations, to factor. So we're going to go ahead, this one is prime, so let's leave it as x minus 3. This is plus. This one is also prime, so let's leave it as 5x plus 4. But now we need to factor the bottoms. So this one factors into x plus 8 and x minus 6. And you always want to think about this for a second. Do I have my signs right? The middle terms are the ones you need to check because the first term and the last term are the ones that you factored them by. So I'm thinking about foiling this now. X times x is x squared. This is 8x minus 6x. That's going to give me the positive 2x. And a positive times a negative is a negative. So I checked that, and I factored it correctly. So that was just a kind of a critical thinking step. Now let's factor this one. It is x plus 8 and x minus 5. Again, the 8 is the positive one because this term is positive. Now, these two have a common factor. The common factor is x plus 8, right? So the least common multiple of all three of those factors is the product of those three factors. my LCM is x plus 8 times x minus 6 times x minus 5. Well, that gets kind of nasty, doesn't it? Okay, but that's the least common multiple. So I'm going to add these together, and my least common multiple, again, is x plus 8.
So you just do the denominator and you just take it back?
Yeah, these are just the denominators. And remember that shortcut that I told you? You can write LCD or LCM down there to save you some time. I don't want to do that up here on your notes.
How is it used?
Because this is in common. You see, this is in both groups.
Yeah.
So I don't need two of those.
Yeah, but how did you get it from 2x to 48 to x plus 8?
Oh, I factored this, right? Do you remember how to factor that? Okay. Factors of 48 that add or subtract to give me 2 are 8 and 6. And factors of 40 that add to give me 8 are 8 and 5. So this is equal to this. And this is equal to this, right? They're just factored. And the reason I factored them is to see if they had any common factors, because that helps me find the common denominator. Okay? So, what did I multiply this one by to get all three terms? X minus 5. So I have to multiply the top by x minus 5 and the bottom by x minus 5, right? So this now becomes x squared, and I do have to multiply them out here. That's why the addition and subtraction ones are a bit longer. So that becomes x squared and minus 5x minus 3x plus 15. So now I multiply them back together so I can collect like terms. All right, what did I multiply the last one by? There's the x plus 8, there's the x minus 5, so wasn't it the x minus 6? So I have to multiply this one by x minus 6 over x minus 6. Okay?
Wait, why do you use that one?
I used that one because it was the one that was missing, right? So, 5x plus 4 times x minus 6 is 5x squared minus 30x plus 4x minus 24. All right, let's take a moment and digest that. So, like terms, x squared and 5x squared give me 6x squared. Negative 5x and negative 3x is negative 8x, but I've got a couple more over here. So I'm really going to put all the x's together. So these two terms and these two terms. So that's 26 and negative 8. What is that, 18x? You guys check me, am I right? No, because it's negative. I want negative and negative, so that's negative 8x. So that's negative 38x plus 4. So it's negative 34x, thank you. And then 15 and negative 24 is negative 9. Okay. Now, the last step, well, we have to do our restrictions, right? What can x not be? The restrictions on the domain, x cannot be negative 8, positive 6, and positive 5, right? And we got that from looking at the bottom here.
Why is it positive 6 and positive 5?
Because you got it. Now, finally, we're ready to see if we can factor the numerator and cancel any of this. So how do we factor the numerator? 6 times 9. What's 6 times 9? 54. Factors of 54 that add or subtract to give me 34 is what I'm looking for. So 1 and 54, 2 and 27. Will 3 go into 54? It should. How many times does 3 go into 54? 1, 18. Okay, so none of these are giving me 34. Well, 4 won't go, 5 won't go, 6 should, 6 and 9, right? 7 will go, 8 won't go, and I'm back here until I'm finished, right? So this is not factorable. If I had to solve this, I could use the quadratic formula, but we're not going there in this unit. We will go there later, okay? So this is finished because you're not going to be able to simplify that. And you should leave the bottom factor. Okay, don't worry about multiplying that back out. You should leave the bottom factor.
You know what you